Welcome to the chemistry class. Today we're going to be looking at volumetric analysis. That's alternative B of the chemistry practical, WAEC practical chemistry. In this very exam, it's going to be a redox reaction this time around. So in this redox reaction, we are titrating ethanoic acid and Potassium Tetraoxomanganate 7. This is an organic acid. Most organic acid, one thing about most organic acid that they need organic reactions. Some of them most of them need heat. It's a slow reaction, so they need to be back up. So that's one thing you should know about this. And this is just my own prediction of the exam. So this is what I was able to get from my own analysis. In the analysis, actually what I use in this analysis is 2 mole of tetraoxo sulfate 6 in acidifying it. So I think that may be why I got something like that, because I've been able to go through some books. I found out that 1 mole can also be used. So what I use here is 2 moles, and this is my value. So in the question I have here is what I say, concentration of E in mole per dm cube, and second question is what concentration of E in gram per dm cube. E is for the organic acid, and E is for the oxidation or this oxidizing agent, which is a potassium permanganate, and also D being the organic acid which you are doing. So in this case, when you have something like this, one thing I want to tell you, if you are carrying out this experiment, is that yes, it's actually, in most cases, you will have a light pink color. This light pink color might not always be like that. Now, note again, this thing, it needs temperature. The temperature, you need to heat it up because it's a slow reaction. So you need to heat it up. And when you heat it, at least something like 40 to 50 degrees Celsius. And make sure you are turning as you're dropping that. Make sure you do it as fast as you can while it's still hot. Because once the temperature is dropping, the slow reaction will continue. It will drop. The rate of reaction will start dropping. So that's why you do it while it's still hot. Shake your conical flask very well as you're dropping it. So you notice that once it goes in there, once the potassium permanganate goes in there, the reaction, gradually the color will be changing until to the point it will be a steady color. Pink will appear. If you allow it to stay for some time, it turns something like brownish. So that does not mean that you are going out of this thing range or whatever. So just note very well, because when you don't put these necessary things, the first drop you have there, you have a pink color, and then it will take a very long time for it to change to colorless, because that first few drops does not necessarily mean that you are getting to your endpoint. So that's one thing I want you to understand here. So when you're doing that experiment, make sure you heat it. Definitely, I tell you to heat it. It must be heated. The next thing, it must be acidified. I believe it might be 1 mole concentration of the tetraoxo sulfate is likely to be 1 mole, because we are used 2 mole. So let's go down and look at what we have here. So based on what we have, this is my values, the values I got from the analysis. So now the first question here says concentration of E in mole per dm cube. Now, to get the concentration of E in mole per dm cube, what we do here is we use our normal formula, which is we have our D, this time is D, and then we have a D again, all over CE, and VE equal to D over E. As the case may be, anyhow you turn it, you still get the same thing. This can go up and this one will come down, depending on the way you want to do it. But then the main thing is that you will also arrive at the same thing. So let's look at the D. Our D here is what? Our D, okay, the first thing we need to calculate the average volume. Why am I so fast? average volume of this used. So from what I have here, see, this one is a bit far away from it, but this other one seems to be at closer range. So what we do now, we can use this to get the average volume. The average volume of what? E. I think that should be E. E used will give us 18.00 plus 18.10. So because they are 2, we divide by 2. So let's see what we get there. We are 36 something. 18 plus 18.1. 36.1. That is 36.10 divided by what? 2. Let's see. Divide by 2. We have 18. We have 18.05. 18.05 cm cube. That's what we have for the average volume. Now we have what the average volume is like for the E that we're looking at. So what do we have here? We don't know the concentration of E. So since we don't know the concentration, we know the concentration of D and then volume of D, which is the volume of the pipette with 25 cm cube. So what we do here, we put the concentration CD is equals to 25. Let me just be a bit fast here. I will not be listing out these things like that, so that will be a bit fast. So this is for this. We have 0.05. That's this concentration of D in mole per dm cube. Multiply the volume. The volume of this is what? 25 cm cube, which I used. 25 cm cube all over. Then we'll come down to E. The E, we don't know this. This is what we are looking for. Then we'll have the volume, which is 18.05. Then we have the mole ratio. The mole ratio for the E, we have that is 2. For this one, we have what? 5. For the organic acid, we have 5. So what we do now is to cross multiply. If we cross multiply, we will have by cross multiplying, we have 18.05 times 5 times C E equal to 0.05 times 25 times 2. So when we do that times 5, we have here 90.25 CE equal to 0.05 times 25 times 2. We have 25.5. So CE will then be 25.5 over 90.25. So what we divide through? 90. What we have is 0.0277 mole per dm cube. That is what we have per dm cube. So the next one we're going to do, we're going to be calculating the concentration in mass gram per dm cube. So to calculate the concentration in gram per dm cube, what do we do here? Conc in grams per dm cube. What do we have? We have 0. This is the molar mass of E. This is the molar mass of E, 158. So that's what we have. 277 times 158. Let's see what we have. So multiply by 178. So we have about 8 grams per dm cube. That is actually what I got from there. But I believe that if I had used something like 1 mole concentration of acid, we might get something different. So this is exactly what I have from my own analysis, and I want to encourage you, if you have come to this far, I want to encourage you to stay with us, and then you can subscribe to us. You subscribe to our channel, and then share. If you have any question concerning whatever I did here, you can also leave it there. I will explain more. I'll give you more details on how to get this thing